Welcome to a new test and teardown video. This time it's another power supply, and it's also from one of my favorite Swedish brands, Oltronix, Stockholm, Sweden. So this power supply is of course a linear regulated power supply, and it's called MB540R, and I believe it is 5 volts 40 amps. So there's not a lot to say about the front panel. You can only turn it on and off, and that's basically it, right? I believe this is a line fuse, 6 or 12 amps depending on low or high mains voltage, and the voltage can be fine adjusted here. It's not a potentiometer, and that is just a trimmer. You need a screwdriver and you can release this and then set the voltage point. As you can see here, we got two different trick points of current. So this is called a fold back. And the reason for having a fallback is, of course, temperature problems. So when current goes to point A, it's set here. And then you go down to B, the constant current point. And the constant current point is adjustable using another trimmer, and that is located inside. And they nicely marked this with a B. So I kind of like that. The top cover is off, and the only kind of top cover this one came with was just this piece of metal, and there aren't any marks from screws here on the side, so it was just pressed down like that. But what I see is some screw threads, so I believe the screws, they were just missing. And that explains why, but I should have seen some marks or something like that. It looks a little bit like copper, but it is copper plated aluminium. And the reason why I know that is that I've been looking at this hole, and you can clearly see some screw was here, and then some kind of a modification or whatever that is. Look at that big, massive mains transformer. I mean, compared to my hand, it is just insanely big. And this unit is 23 kilos, 19-inch rack. And we got a little problem with a bent corner. Obviously, if you drop this just a little bit, you're gonna get parts bent. So, because it is just so heavy. So this copper plated aluminium is just to make it look sexy. I mean, I think there's no real need for that. I can see one huge capacitor here, and that is basically the main charge capacitor, and power goes straight through. This is probably a fuse. Look at that. That gotta be the fuse, and it's soldered. And because this is a 40 amp fuse, they just solder it like that. So normally you have quite a lot of loss if there is a fuse socket of some sort, right? And this is to avoid the big temperature loss, and they are also cooling each of the ends with this. So that is quite nicely made, really. We got some smaller capacitors, one here, and there's one hidden in here. It's probably, I don't know how deep that is yet. And there is another little problem I want to show you guys. This is the mains on-off switch. And look at the back position here. Can you see the distance through the metal? I mean, it is just non-existent, like a millimeter or 1.5 or something like that to the transformer metal. And I believe that maybe when this one was dropped and the front was bent, maybe the transformer moved a little bit in this direction, causing this distance to be this small. So I want to loosen those screws and see if I can move the transformer that way. So that is my first little modification. And I also see that we got some screws missing here. Those are M2.5, by the way. So that is a little bit untraditional. And the whole case is one big heat sink. How amazing. It's a beautiful, beautiful heat sink design. And that is very, very classic for Oltronix. More or less all their power supplies, they're just heat sinks all over the place. And this is more or less how they do things. And if we move these out to the right, we can see some big, hefty diodes. And there's probably also a diode of some sort here, or an SCR for overvoltage protection, and that is probably the overvoltage set point, because there's an off and a trimmer and a Zener diode, right? So that will be the output SCR protection, and that will be diodes for rectification. I don't understand yet why we have 3 and not just 2, and that will be output regulators. And we also got one more here at this side. There is one transistor, I can kind of feel it under here, and that is all there is in this side. Why are you having 4 transistors here, none here? I mean, that is a weird thermal decision, and there's nothing under that protective cover here on that side, not a single transistor or anything at all. So I find that a little bit weird. Let's try and flip this around and see what else is hidden here, right? But before we do the flippity flip here, let's have a look at this little controller board. So this is the output voltage regulation, fallback current regulation board. And this is all there is to it. See, thermally coupled transistors, nicely marked with some different colored paint. And here's a little Zener diode, and that is all there is to it. And of course the 2 potentiometers and all that. It's quite beautiful, the design, really. And I also like the front mounted bananas. You just take your voltmeter and stick it in to test the voltage or test the current. So this is probably a current test probe. Maybe there's a sense resistor somewhere. Let's go and have a look if we can find that. So this is the bottom side of this monster power supply, and I think I was right about a lot of things that I already imagined. Let's try and look a little bit at the circuit here. So this is the mains transformer, and of course it's a center tapped output. So we got 2 wires here, and that will create a positive using those 2 diodes, right? And that will be, the positive, and this output goes via a very large inductor. And this is very, very smart, because it smooths the current, so the current peak takes a lot longer time, and therefore charges the capacitor using a more smooth current instead of a really, really evil peak current. So this now smooth current goes via the fuse and to the capacitor. But I really like the idea. The fuse here is before the first main charge capacitor, because if this is shorted or something is bad with the capacitor, you want the protection to protect as much as possible. Of course, it's not protecting if the diodes they are shorted. So a real smart way to do it could have been adding 2 fuses, one here and one here, right? Then it would be fully protected against whatever could happen. But anyway, main charge via the fuse, big hefty capacitor. So we got 2 capacitors, smaller capacitors, right? One is of course for the regulation circuit, and the other one here is the output. See, those 2 big cables, they go here in the back to the terminals at the back. You can probably see them right here. So this is the back panel. And you also see the output goes to this diode right here. So that will be the 3rd diode. That is output. So this is a reverse diode. If you input voltage in reverse, for example, if you got 3 of these or 2 of these in series, and one is going into current protection before the others, then you will have reverse voltage into it, right? And that is what you don't want. So that is why this diode is here over the output. And that diode must, of course, be able to handle full current. And that is why you have this big, hefty diode like that, right? And we got 4 more transistors. So we got 8 of them in total. TO3 style transistors. And it's, of course, not a surprise, a 3055 transistor. So 8 of them in the output. And there's another one here in the side. That is the driver. And then we go into small signal transistors. And exactly what I said earlier, that is a big hefty SCR, and that one is of course over the output. So in case the output or the voltage regulation is failing for whatever reason, then this one will just short the output, blow the fuse, and save whatever kind of expensive equipment you may have connected to this unit. So when I power this up, if it pulls a lot of power, it's probably because the SCR here is shorted or tricked. And probably because I will turn this up slowly and see what happens. And then we'll see, yeah, this is going to be quite interesting. I don't see anything preventing me from powering this up. I can also show you the emitter resistors, and I believe the emitter resistors here, they're all the same, and that is also what they're using to measure the output current, and that is what we can measure here at the front panel, the voltage drop over one of the emitter resistors. Or are they sharing the emitter resistors voltages or something like that? I don't see that. It's quite simple, the circuit really. We can more or less figure out the entire circuit by just looking at this, right? So there's just one more thing to show, and that is the back panel. So we got sense, and we got all the outputs. Quite a lot of wires here you can put in parallel. And behind this little panel, see, test. Pretty cool, huh? So that's just some test points where you can measure. I believe that will be all the different transistors. You could probably measure, see, I don't know. I cannot find any schematics anywhere online. So if you happen to know where to find the schematics, please tell me. But I believe that will be some important test points for the output transistors or the drive circuits or something like that. And we got some parameters. So this is a switch to select normal or parameters, or that means it's external instead of internal voltage control, right? And that will be the big hefty mains entry connector, super old style. I just happen to keep these old style connectors, so here we go. And that is a little loose, really. Look at that. So this bracket here is what holds the entire mains transformer, and this is in some sort of a sliding groove. So I just loosened those 4 screws, as you can see here, right? This one and that one, and moved the entire transformer bracket. Look at the distance. We got like 4 millimeters, 3 or 4 millimeters now. So now it's nice and safe, and I can continue to power this up without risking any arc over to mains. We don't want to see that. I've been doing a little bit more inspections and research, and I don't know if you remember earlier in the video we had those 2 reefer capacitors like that. Let me show you the big one. It's completely cracked, and this is a classic reefer problem, but lucky for this construction, this is at the secondary side, the low voltage side. So this is just over the diodes. So, but anyway, I changed both of them because I really don't want cracked reefer capacitors. Also, I wanted to show you, this is the driver and this is the pre-driver transistors. And then, of course, we got 4 here on the top and 4 at the bottom. And that will be all the test points. Remember earlier I showed behind this plate, we got test, and we got all the different points marked with little letters. And that will be the letters for each transistor. They are named with a little letter. So you can easily measure which ones are working or not. I think I'm ready to do the first power on, and what I want to do is, this is line on. So I just, yeah, it's upside down, sorry about that, but this is the way that I can see what is going on, right? That will be the test voltage from the front. I believe we got 2 really thin wires going all the way to the back. Maybe there's a little resistor in series or something like that, so you can't pull any current through this output, but I think this is just for a voltmeter. So what I want to do is I want to power this thing up. So let's try the power up. This is connected directly to the voltage check here at the front, and the other meter here at the back is connected to the output at the rear, right? And then I'll try and crank up the mains voltage. And as you see, we get a negative voltage at the front check and 0 at the back. And this is 150 volts and it's using 5 watts. This is 220 volts. I don't know if you can hear this. 12 watts idle. This is most likely the main transformer, but we don't see any kind of problems like that. Oh, line switch is not working. That's interesting. It also feels a little bit weird. So this one is totally welded together. See? That is funny. But anyway, the unit is not working and it's only 12 watts idle. So I will start to investigate a little bit here. I am quite happy to tell you I figured this out in my first guess. And of course, if we look here at the back, I don't know if you can see this, but this is the sense. Here is sense. So sense was not connected to the negative output, and sense was not connected to the positive output. And I believe that is what caused the problem. And sense positive and negative, they go directly to the front. And it also drives the electronics. So if you don't have your sense correctly mounted, you get zero output. Isn't that nice? So let's try and power it up again. And it is adjusted for 3.8 volts. And if I... Can you hear this? This is the input voltage. I changed the input voltage on my Vario. So this proves the unit is regulated. So I believe it works. I will try and poke around with the voltage sets. So I think I'm about to be done with this power supply. As you can see here, adjusted the output for 5 volts, and the other output, the current check output, let's see what happens with that one. So I connected 2 of my loads, and here we go with 5 amps, and so 5 amps is about 50 millivolts. Let's try and crank up the load with another 5 amps. So that will be 10 amps, right? And about 100 millivolts. So that is about 50 watts of output in total, right? And my input power consumption is 120 watts. So it's not too bad. I did take my thermal camera and measure a little bit around here, and I really don't see anything alarming at all. I have a little drive transistor down here that runs about 45 Celsius. So it's perfectly fine. So that is one nice linear power supply. And all I have to do is figure out to change the on-off switch and see if I can straighten this little piece of aluminium here, but that shouldn't be too difficult. So thank you very much for watching. Bye bye.